We're going to take notes on 9.4. 9.4 isn't much different than what you did in 9.3. Almost every single thing is the same except a couple of things. We're going to be talking about the surface area of a cylinder instead of its volume. So the surface area of a cylinder is made up of twice the area of the base plus the lateral area. This key word, lateral area, means the area around the sides. You can kind of think of the word latitude. There's latitude and longitude as far as direction goes in geography. Lateral area means the distance around the sides or the distances around the bases. When I think of a cylinder, the top and the bottom are the area of the bases. The white part, the sheeting around the coffee can, that is considered the lateral area. Lateral area, just so you know. So the way this formula works for a cylinder, I'm kind of hoping you can see it, is that you have pi r squared, which is the area of a circle, and then you have two of them. This first part adds up the areas, the two of them, of the top and the bottom. And then you're adding the lateral area to that previous area you found from the top and the bottom. How do you find it? It's the distance around the cylinder, 2 pi rh, that's the circumference formula, multiplied by the distance between the two bases. That's what h stands for. Some of the problems you're going to have to use fractions to figure out what the answer is, and I'll show you what I mean. I have an example picked out for you. And lastly, when given the volume, write out your equations and work backwards to solve for the unknown variable. There'll be a few of those as well. So here are the examples that I have chosen for us to do together. There are 3 of them, 5, then 8, and 12. If you want to do these in your packet, you are welcome to do so. Suppose that a cylinder has a radius of r units and a height of 2r units. From here to the edge, the radius is r units. They don't give you a number. They give you a variable. And the height from the top of the cylinder to the bottom of the cylinder is 2r units, twice the radius. Oh, you can't see that, so let me scoot it over just a bit. There you go. The lateral area of the cylinder is 64 pi square units. What is the value of r? So if you're figuring out what the lateral area is, that's the distance around the outside. You could think of it as what is the label of the coffee can or vegetable can or whatever kind of can you're thinking of, okay? Think about what goes around the coffee can is what we're looking for. So if I think about the lateral area, I'm going to use this part of my formula only, the 2 pi rh, 2 pi rh. So let's come back to here. My lateral area is equal to 2 pi rh. It tells me my lateral area is 64 pi. 64 pi equals 2 pi. What's my radius here? R. I plug R in for R. What's my height here? 2r. Plug that in for h. So what we're left with is this. We're left with 64 pi equals, I'm going to multiply 2 times 2, which is 4, pi. R times R is R squared. I want to figure out what r is. I'm going to divide, not just by 4. I'm going to actually do this in 2 steps. I'm going to divide by 4 pi because then the pi's would cancel and the 4's would cancel on this side. What I would be left with on the right hand side is r squared is equal to pi goes into pi 1 time, 4 goes into 64 16 times. Does that sound right to you? Thank you. Now I have r squared equals 16. So to get rid of that square, I'm going to square root. When we square root, normally this is a positive or a negative 4. But if we're talking about a radius or a distance, will we ever use the negative value for that? So really, even though we've done the math and the math says positive 4, negative 4, we only know that the radius is the only radius that makes sense is 4 units long, a positive 4 units long. That's our answer for part A. Part B, what is the surface area of the cylinder? Well, now that we know what the radius is, we can plug it into that formula. What's the formula for a surface area? Surface area is, and if you don't know, you should be starting to try to memorize the formulas. I'm going to just do this off the top of my head. I know that I have a pi r squared. That gives me 1 circle. Wait a second, I need the top and the bottom. 2 of those. Plus my lateral area. How do I find that? 2 pi r h. The circumference times that distance from base 1 to base 2. Now that I know what value r is, I can plug that value into where the r is. Now that you know what r is, do you know what the height has to be? We didn't figure that out, but I bet you we could do it in our heads. Has to be 8 because it's double whatever r is right there. Now let me see what these directions say. Round your answer to the nearest square unit. Does that mean I plug in the values of pi in? Absolutely. I recommend do not round until you get to the very end of your problem. I also recommend when you punch this in, use the pi button on your calculators. For the Casios, I don't know if you could see this, but it's right here above the times 10 to the x. There's the pi button. To get to it, you will press shift before you get to that pi button. So I'm going to type this in. 2 shift pi times 4 squared plus 2, bless you, times pi times 4 times 8. And as I told you before, what I like about these calculators, I can look to see, did my chubby fingers, my fingers are sometimes chubby, did they punch all the buttons in correctly? Did my nails get in the way? Sometimes I need to cut my nails. There you go. I just say that for you ladies who have long acrylics on. Equals. It says 96 pi, but I'm going to round it to the nearest square unit. 3, 0, 1.59 rounds to the nearest square unit. 2 units squared. So far, so good. Now, let's go to our next example. Find the surface area of each solid. This one's a little bit funky. There's no formula. There's no one formula that's going to work here. We're just going to have to figure this thing out as we go. I have this front, which is a nice rounded shape. I have this rectangular prism over here, but I can't use the rectangular prism surface area because I don't want to count this left side. I want to ignore this part of that rectangular prism. So what I'm going to do first is I'm going to figure out the area of this guy. The surface area of that. This is where a fraction would come into handy. Instead of a full cylinder surface area, how much of the surface area are we going to figure out? Half of the surface area of the cylinder. What does that mean? That means we're going to do half of 2 pi r squared. What's r in this case? 2 pi r squared plus 2 pi, the radius r, h. Why does it do that? I don't know. That will give me the surface area of this cylinder. Top, half the bottom, plus half of that distance around the outside. So I have the half in parentheses. I am going to multiply it after I figure out what's inside parentheses. Now what I'm going to add to that is I need, let's switch colors to blue. I need this, the bottom, and the back. So if I want all of those, the perimeter right here to here to here to here would be a great thing to know. The perimeter from here to here, let's figure this out. If this is 6, that would mean the radius is 6. If I color in this little piece right there that I'm coloring in, that has to be 6 as well. The other radius would have to be 6 as well. Do you know what this distance is that they did not give you? It's 12. That's important for you to be able to figure out. How did I do that? I used the fact that they gave me the radius of that cylinder, of that half cylinder, and I used the fact that if you double the radius, you get the diameter. And now I can figure out what the perimeter of this thing is. I have a 10, another 10, a 12, and a 12. The perimeter of that base is 10, 20, 30, 44 times by the distance from this side to that side. That gives you your blue piece. There's only one piece that I have not added in this whole equation, and that is this very back piece. I'm trying to color it in green. And base times height will work perfectly for that. Now I have every single part of my work shown. If I make a mistake on my calculator, Mr. Promo can look at my work and see that I knew what I was doing. Make sure that you have your work shown before you do it. You could even write out what the equations if you wanted to. Now I'm going to figure these things out piece by piece. Let's go ahead and plug in this first thing. 0.5 times parenthesis 2 times pi times 6 squared plus 2 pi times 6 times 10, end of parenthesis. This top is 96 pi is what I was getting. 96 pi. I'm going to put 96 pi right there. Plus 44 times 15 plus 120. So now I have 96 pi plus 660 plus 120 And I'm getting 1081.59. Does it tell me what to round to? No. So I'm going to round to the nearest 10th place here. And because we're talking about surface area, I use centimeters squared. Is that the only way to do it? Nope. You could have figured out the surface area of the whole thing and subtracted the other red piece. You could have done some things like that, but last one. Oh, Jared, go ahead.
Did you have to do 2 times the base?
Did I not do it?
No, you would do 12 times 10 to get the original base.
2 pi r squared. Pi r squared.
For the rectangular prism.
But for the rectangular prism, if I go this distance and that distance and that distance and that distance, that's going to figure the top, the side, the bottom, and the back.
Yeah, perimeter, but it's the whole surface area of the prism is 2 times the base plus the perimeter times 15.
Right.
You didn't do that. You did 12 times 10 and that was it.
This is because, see this green side?
Yeah.
That figures out this base. Do I want the surface area that's inside this thing touching that cylinder? I don't. I don't want to add that because I'm thinking of it as only the outside covering. I don't want to add in that extra piece. That's why there's only one base. So I'm glad that you asked that question. I did that on purpose. It's the hardest part of seeing these shapes. Surface area, think of the shell. Not the chocolate inside the shell. M&M's. All right, last one, number 12. Find the value of x to the nearest tenth. They give you the volume. So I look at this shape and I go, okay, I know what the volume of a triangular prism is. The volume is equal to the big B times the H. Big B would be this triangle. I need to know what the area of the triangle is. In that formula, since it's a triangle, I know that this is 1/2 the base times the height that are perpendicular to each other. And the height in this formula is talking about the distance from one base to the other base, which is going to definitely be x in this case. So I know what the volume is. The volume is 576 centimeters cubed. I know what the little base and the height is of that triangle. It's 8 and 8. 8 centimeters and 8 centimeters. So at this point, I can simplify the question. I can do half of 8 times 8. 8 times 8 is 64. Half of that is 32 centimeters squared. I'm going to do this with units just because I can. A lot of people ignore these units, and what's really neat about it is you can actually leave it in here and you'll figure out what x is in terms of the correct units. 32 centimeters squared times x equals 576 centimeters cubed. If I divide by 32 centimeters squared and divide by 32 centimeters squared, watch what happens. Centimeters squared goes away. 32 divided by 32 goes in one time. You're left with 1 times x, which is just x equals centimeters to the third divided by centimeters squared. 2 of them, subtract from here, you're left with centimeters. Kind of neat how that works out. And then I have 576 divided by 32, which I don't know what that is. I'm going to use my calculator for that. And I can figure out what my variable is. If you would like, you could plug it back in to verify that it works. but I'm positive that it does. Any questions? We'll stop your notes right there.